we have the infinite series of 1 divided by 5 plus 2 to the n, and we want to use what's called the direct comparison test to show that this infinite series converges. The direct comparison test sometimes is also called the basic comparison test. And it says that if we have an infinite series A sub n, if it's less than or equal to the infinite series B sub n, and if B sub n converges, then that also implies that the infinite series A sub n converges. And then it also says that if the series B sub n is less than or equal to A sub n, and if the series B sub n diverges, then the series A sub n diverges. And for this particular example, we want to show that the series 1 divided by 5 plus 2 to the n converges. And so we will call this right here A sub n, and we need to come up with a B sub n, and then show that B sub n converges. And then and that's how we will show that the series 1 divided by 5 plus 2 to the n converges. And so first, we will let A sub n be the sequence right here. 1 divided by 5 plus 2 to the n. And then we'll let B sub n be something similar. So we'll let B sub n be 1 divided by 2n, which is drop the constant 5. And this is the same as 1 divided by 2 to the n. And now let's compare. One divided by 5 plus 2 to the n, we want to compare it with 1 divided by 2 to the n. The denominator 5 plus 2 to the n is larger than 2 to the n. Five plus 2 to the n. This is larger than 2 to the n. And so that means that 1 divided by 5 plus 2 to the n is less than 1 plus 2 to the n. So this denominator is larger, and so if we do the reciprocal, then it would be smaller. And so from here, this series will be less than this series. This is the series A sub n. this is the infinite series B sub n. So this is A sub n, this is B sub n. So we call this right here B sub n. And this is equal to 1/2 to the n. This series right here is a geometric series with common ratio r equal to 1/2. And since r of 1/2 is between -1 and 1, this series right here converges by geometric series test. Remember that the geometric series test says that if we have a common ratio between -1 and 1, then the series converges. And so we have the series A sub n right here. This is A sub n. And this is the series B sub n. So we have the infinite series A sub n less than B sub n, less than B sub n. And we have also shown that the series B sub n converges. And we have shown that this series right here converges. And therefore, by the direct comparison test, or sometimes it's called the basic comparison test, this series right here converges. And again, when we say that a infinite series converges, we're saying that this infinite sum right here, if we add all the terms together, then we get a real number. And so this series 1 divided by 5 plus 2 to the n converges.